Hi, this is Dr. Crisostomo, and this is Chapter 4, Basic Probability. Now, you're probably wondering why are we learning about probability? Well, believe it or not, statistics has to do with a lot of probability. So, for example, I saw this article this weekend about a woman who negotiated $4,000 from an airline after giving up her spot on an overbooked flight. So, if you have ever gone on a plane or bought a plane ticket, you may have been sitting in the terminal and you might have heard the announcement, ladies and gentlemen, we are in an overbooked flight situation. If you're willing to give up your seat, we will give you a X amount of dollar voucher for a later flight. And at first you might be wondering, well, that's unfair. Why are you selling more plane tickets than you actually have seats for? Well, these statisticians, they look at the probability that if they sell out every single seat on an airplane, what is the probability that everyone will actually show up? Now, that probability is probably low, looking at people who forget to set their alarm and they miss their flight, or they get stuck in traffic, or something comes up where they cannot make their flight. So that is a lot more probable than having everyone who has bought a ticket show up. So it's worth it for the airlines to overbook a flight because the probability that everyone will show up is a lot lower than the probability that someone is not going to be there even though they've purchased a ticket. And when they have this overbooking situation, they can offer that voucher. Yes, they're losing out on money, but in the long run, by overbooking the flight, they're making a lot of money. Otherwise, if they only sold enough tickets for the amount of seats on a plane, and somebody doesn't make it to the airport in time, now they have a empty seat. So it is worth it for them to overbook the flight. Again, they're looking at those probabilities, right? Because if the probability that everyone shows up for this flight for the exact number of seats, if that happens all the time, then it wouldn't be worth it to overbook the flight, because then they would be losing money for giving these vouchers to people who do give up their seats. So again, we have to understand basic probability because it can drive a lot of business decisions. So here are the objectives for this chapter. And a couple definitions to start out. So probability is the chance that an uncertain event will occur. And that probability will always be between 0 and 1, where a probability of 0 means that it is an impossible event, an event that has no chance of occurring at all. Whereas a probability of 1 means that that event is sure to occur. It will always occur. And there are 3 approaches to assessing the probability of an uncertain event. We have a priori, empirical probability, and subjective probability. So for a priori, that is based on prior knowledge of the process. So if you have some sort of information about that event beforehand. So for example, what is the probability that you draw a 4 from a deck of cards? You know that there are 52 cards in a deck, and then you also know that there are 4 fours in that deck of cards. So again, that a priori would be based on prior knowledge of the process. Empirical probability, on the other hand, is where you don't really have prior knowledge. So for example, if I want to know the probability that my students have children, I don't have any knowledge on that at all. So I would have to see how many of you, I have this many students, and then how many of those students have children. And then subjective probability is based on a combination of those individuals' past experience, personal opinion, and analysis of a particular situation. So it's a little bit more subjective, obviously. For example, what's the probability that a student in my in-person class does well in does well in the class but does not show up to any of the lectures, that probability is really low. And that's anecdotal, right? I don't have actual data on that. But it seems to be that if you aren't showing up to class, aren't attending the lectures, then you probably aren't going to be doing well in the course. Here's just another example of the a priori probability. So when randomly selecting a day from the year 2015, what is the probability that day is in January? So X is the number of days in January over the total number of days in 2015. You have 31 days in January over 365 days in 2015. So you have a 31 out of 365 chance that that random day that you've selected is a day in January. Again, this is a priori because we have prior information about the number of days in January as well as the total number of days in a year. Here's an example of empirical probability. So find the probability of selecting a male taking statistics from the population described in the following table. So I don't know any information about male or female makeup of that population or who is or is not taking stats. So I'd have to observe that information first and then take the probability from that. So from this chart, it looks like we have 84 males taking stats out of the 439 people that I've sampled, and that'll give me a probability of 0.19. And again, that probability, if it's closer to 0, that means it is less likely to occur. So it seems that there is a lower chance that if I randomly select a student from the population that it is a male who is also taking statistics. Again, here's another example of subjective probability. So a media development team assigns a 60% probability of success to its new ad campaign. However, the chief media officer of the company is less optimistic and assigns a 40% chance of success to the same campaign. So they're bringing in different experiences, different knowledge, anecdotal information, so that subjective probability can change for that same event. It is important to know that subjective probability is useful in situations where an empirical or an a priori probability really can't be computed. There are also different types of events. So a simple event is an event described by a single characteristic. So for example, a day in January from all days in 2015, a male student from WT. A joint event, on the other hand, is an event that's described by 2 or more characteristics. So a day in January that is also a Wednesday from all days in 2015, or a student that is male who is also taking statistics from the WT population. And then the complement of event is all events that are not part of that event. So going back to the simple event we described earlier, which would be a day in January from all days in 2015, the complement of that would be all days from 2015 that are not in January. A sample space is the collection of all possible events. So if we're looking at dice, the sample space would be all 6 faces of a die. That's all possible faces. Or if we have a deck of cards, our sample space is all 52 cards of that deck. And here's a visualization of those terms that we are talking about. So sample space would be all days in 2015, which would be represented by this box. This circle would represent January days, so all the days in January. And this red box would represent all the Wednesdays in our year of 2015. And the Venn diagram, or this part in the middle, would represent all days that are in January and our Wednesdays. So this is where our joint probability comes from. Simple probability refers to the probability of a simple event or something that has just one characteristic. So we can look at simple probability by looking at this contingency table, and you're basically taking just these totals here. So what is the probability that that day is a Wednesday if you randomly picked a day in the year of 2015? Well, here's our total column here. 52 out of 365 would be the probability that it is a Wednesday. And 365 is the total number of days we have in our sample space. We can also look at joint probability with these contingency tables. So again, joint probability refers to the probability of the occurrence of two or more events. So what's the probability that you pick a random day in 2015 and it is not January and it is not Wednesday? Well, the probability that it is not January and it is not a Wednesday is right here, 286. Again, we divide it by our total sample space. So the probability it is not January and not Wednesday is 286 out of 365. What's the probability that we pick a random day and it is a Wednesday and it's in January? Well, here we have Wednesday, January, and it's 4 out of 365. So this may seem very familiar because we did calculate percentages in chapter 2, but this time we're just wording it in the terms of probability.